basically recursive application of the chain rule backward through the network. You're right. Yep, you got to calculate the gradients, which is just, it's just the delta across the layers, right? And so there's a matrix. When you each of your layers is a matrix, right? A two-dimensional matrix. And when you're calculating, the loss, and then you're applying the loss to you're creating a gradient, which is just another array that tells you how to update all the models and weights, right? It's the difference. And then you multiply it by the learning rate. And then you apply that, or you add or subtract whatever direction you're going on your model. And then your weights and parameters slowly learn over time. And that's how everyone are going to be doing today we are going to be doing our neural network with Pytorch. A neural network with Pytorch. Computational graphs and autograd are very powerful paradigm for defining complex operations, automatically taking derivatives. However, for large neural networks, raw autograd can be a bit too low level, which means that we need something that's going to help us take care of, especially if we have a lot of layers all together. We don't want to deal with the math with us automatically or directly. So when building neural networks, we frequently think of arranging the computational into layers. Essentially, we've got a whole bunch of matrices, right? So you've got each layer is a matrix, a 2D matrix, right? It's a 2D matrix. We're getting to some of the code now. In Pytorch, the NN package serves the same purpose as, the Keras and TensorFlow and the other high-level language. Though we're going to do Python because we got Pytorch, and I want to learn a little bit more Pytorch. I'm used to writing it all by hand myself, and I want to get better at the frameworks. And so that's what we're doing today. All right, so the NN package defines a set of modules which are roughly equivalent to the neural network in layers. A module receives input tensors and computes output tensors. Okay, so the input is an array of a multi-dimensional array, tensors, right? Let's do it. In this example, we use the neural network package to implement our polynomial model network, which is going to be able to learn a sinusoidal wave, it looks like. We're going to do a sinusoidal wave, a linear space. And then I'm actually really curious. Are you guys ready for this? All right, let's get started here. We're going to pop open here. All right, I'm going to paste that in. Let's save this and run it. Python run in n.py. All right, I want to print y. Let's see what that looks like. We're going to print y. So what we've done here is we've created, I believe, our tensors. We've created some tensors. So on the screen, on those on the TikToks, you can't see it, but we created two tensors. One is a line space, which I'm not exactly sure what is this made of. It looks like the input data. And then we've got a sine wave based on, okay, so it's going to give us sort of like negative pi to positive pi. That's all right. So we got a lot of, we've got our initial inputs and outputs, right? So we're going to train a model to learn the sine wave, essentially. I think that's what we're doing. We're doing on sine wave, so based on -3 to +3, essentially. Why are they doing this? Why don't we just do this right here, right? I suppose because this is a full pi would represent complete circle. It will represent a full circle. Hey, D6559, what are you doing? What is Pytorch used for? It's used for training AI. It's a machine learning framework that allows you to construct your own AI model and then train it. Back here on our code. Let's jump back in here. Let's bump back in here. Okay. So we've got, for this example, the output y is a linear function of x to the x2 of the x3. So we can consider it as a linear layer network. Let's prepare. Why are you using sine function in the is the order encoding? We're going to learn the sine function. We're going to teach the AI how to draw a circle. That's what we're going to do. We've got the sine wave, which is the output, right? So we've got an input. So you just give it a number between -3 and +3, essentially. And then the AI will be able to draw a circle based on that. It'll be able to draw a circle, a near perfect circle. I think it's pretty neat. Okay, so in the above code, unsqueeze has a shape of 2000 to 1. Okay, so let's look at this. Let's look at this code right here. We're going to pipe over here and then drop down over here. Okay, so let's see what P looks like. Let's print P and XX. Let's see what those look like. Oh, wow, look at that. Wait, hold on a second. Wait. Oh, okay. So we took the X, which is the -3 to +3. We unsqueezed it and then multiplied it by P, 1, 2, 3. Okay. So what we've done is we've created a projection of some sort. P.tensor, right, is going to just be a 1, 2, 3, right? And then we're going to multiply the number. So check this out. Look at this. You can see. So we start out with -3 and we go to +3, but you can see how it sort of multiplied across C. So we can see the transformation that we made here. So check this out. So you can see that we multiplied the P tensor with the X tensor, but we unsqueezed it by -1, which means to me that I'm actually kind of curious. What is the unsqueeze? Let's read the docs real quick. Here we go. In the above code, the X unsqueeze has a shape of 2000 to 1. Oh, wait, are you sure? Because that's not how I'm reading it here. It does not look like, oh wait, maybe it does. Here, let's actually, what we need to do is see what this is. Let's do this real quick. Let's do a print this. We'll print, so it really was a 2000 to 1. And then broadcasting, all right, so let's see here. We'll apply to obtain a shape of, okay, so 2000 to 3. Interesting. So now we have a whole bunch of numbers in this dimension of a matrix. It's a 2000 by 3 matrix. All right. Sounds good to me, which means that our input needs to be at 3. And then, so this might be a batch. There'll be a batch size right here. Okay. Use the the NN package to define our model. And thank you for the likes, you guys. As a sequence of layers, NN.sequential is a model which contains other modules. Here we're jumping back into it. So now that we understand our inputs data here, let's make the model. So we'll make the model, we'll copy and paste the model. This is a really simple model. In order to learn how to draw a circle, it's really simple. Linear model, which is just a multi-dimensional array, right? And then we've got a flat, which, why is it 0? What does 0 mean? Zero dimensions? Is that what that means? Let's find out. So the flattened layer flattens the output of the linear layer to a one-dimensional tensor to match the shape of y. Okay. And the shape of y is only going to be a 1 output, right? So it's just 1. The idea so you see here on the screen, mean squared error, is just the idea of taking all of the outputs from the model that you've given it to it, and then it's going to, I believe, multiply it by itself, right? It's 2x, so it's going to multiply it by itself, and then it's going to sum all of the outputs into a single value. And then it's going to be applied over during the backpropagation in the optimization function using that value. That's all it does. It's a really simple algorithm. Mean squared error. Check this out. MSE function in Python. Check this out. It's very easy. It's very simple. So you just take the inputs, so you get the actual output and the predicted, right? So the output of the model and the predicted, which is going to give you the delta, right? The delta. And then for all of the answers, you're going to calculate an error, and then you're going to apply a square over it, right? So you're going to say you're going to add it to an array, all the outputs. You're going to subtract the error based on the prediction, because it's the batch, right? The batch itself. You're going to multiply it by itself, and then you're going to average it. That's it. Think of it as penalizing for big mistakes. Yeah, okay, got it. That's actually a really good way. If you predict y is too far from the real y, this is a big difference, and it gets squared. Got it. Oh, so your extra penalty. An extra penalty. You want to be penalized? Well, we're going to double that, or like square the penalty. It's going to be extra penalty for you. So you're going to make it even more penalized. So there you go. And then that will be applied during the backpropagation to calculate the gradients. And then you multiply by the learning rate on the weight model, on the model's weights and biases to slowly allow the model to learn whatever it is you're trying to. I'll grab all the code here, and then we'll just paste it in directly. PB paste into NN. There we go. Vi NN. There we go. So now we've got all of the data. All of our code is there. And then we're going to be doing a 2,000 batches. Delta, you mean? Yeah, delta or difference, right? Delta or difference, right? Or the loss or the error, like the error, delta or difference. They're all the same. Let's run it and see what it looks like. Okay, so did it learn? It did a little bit. It learned a little. That's why, interesting. Look at this. It's because we're manually, it's doing something that I was not expecting. It's actually going in directly and grabbing the gradient, multiplying the learning rate, and then adjusting the parameter directly. Isn't this a framework for deep learning neural networks? So this is where, okay. So this is where it gets simpler. Here's where it gets simpler. So if you want, so up to this point, we've been manual. I know, see, this is what I was talking about right here. And I told you. All right, so check this out. Here's what the tutorial says. Up to this point, we've been updating the weights of our model by manually mutating the tensors holding the learnable parameters. I was like, what are we doing? We're using a framework. The framework is supposed to do that for you this whole time. I thought that was crazy. And I was confused. I'm like, this doesn't make any sense. Why is this happening? Oh, here's this why. Because we are manually doing it and we're using a framework. All right, so let's jump into it. Now we can do, we did no grad. That's why there was no grad and we were popping out on the no gradients. I was like so curious about this. I was like, what are we doing? Why are we zeroing out the gradients? Why did that happen? We're calculating the loss on all the parameters and then we're updating manually. I was like, what's going on here? This is so weird. But it totally makes sense now. It totally makes sense. So is this the same? Let me double check. It is. Okay, so this will also. Okay, perfect. Let's go into more of the framework. Let's dive into the framework a little bit further. So let's PV paste neural network. Let's reopen neural network. Okay. So it's all the same before, all the initial stuff. Same model, same loss, mean squared error. This time, though, we're using an optimizer that is built in, and we'll be able to directly use the framework's optimizer instead of writing our own optimizer, which directly applies the learning rate into the weights. So we don't have to manually do it, which is the whole point of the framework. This is what I like. This is what I like in a framework. We're going to run the model over 2,000 batches. This is not epochs. Well, actually, technically it is. It's technically epochs because this is a full batch, 100% batch. So we're going to be doing all in and all out, all at the same time, which is not usually how you train models, especially deep learning models. You typically take a large amount of data and then you spread that out over several training batches. In this case, we're doing 100% of the data all in one batch, which is a lot. This 2,000 samples. It's insane. It's insane. And then we're going 2,000 epochs over that. So here is, it looks like, okay, so, yep. So 1, 2, 3. So it's, the input is 3, right? So here you go, 3. This is the input. It is 3 values for each of the models. For each value that gets thrown into the model, it's 3 inputs, which makes sense because our input layer is right here. So check out, the input layer is 3. So this matches right here. Try it out. Let's try dot value first. Let's see if that works. Like, we'll try dot value. All right, pull that over here. Doesn't like that. Let's try item. Try item real quick. Let's see. Oh, it worked. Okay, dot item. Perfect. Thank you, user. Thank you. This is what I was looking for. All right, so this is the value. So we could essentially draw a circle using this data generator. Now we're in business, right? There we go. That's what I'm looking for. Okay. Now we can see a little bit better. This is what I want to see. All right, perfect. So now we can see what the sine wave looks like. So see, it's increasing. It should increase and then it should decrease. Is what it should do. Increase and decrease. Right? So yeah, there it goes. See, it decreases. I told you. And then it goes down to negative, and that's the bottom side of the circle. This is the bottom side of the circle, you guys. The bottom side of the circle. Isn't that cool? Right here. So we could draw this. So we could draw this essentially. We just need to update. We need a way to draw it. All right, this will be the last thing that we do. We'll draw the circle. This will be the very last thing that we do. We'll click draw on the circle. So let's see here. So you see how it goes almost all the way up to 1. Almost all the way. So, all right. So what we got to do here is draw this as a, let's see, graph. Let's see if we graph the results. All right. Let's see if we can visualize this here. Let's have the AI help us out to draw this we're using matplotlib. I'm pretty sure I have matplotlib installed. Pip install matplotlib. Let's see. I'm pretty sure. Oh, I didn't. All right. We had to get it. We grabbed it there. All right. We're good to go now. Okay. So now we need to, we did not give it any data yet, so we need to give it data. Here we go. That is not what we want. We want to print. We need to print O. We need to print the output. So is this dot show? There we go. I know this is the thing that shows the P. There it goes. Okay, check it out. That's it right there. Okay, so check this out. Okay, so what we did was we trained the AI. It's almost a circle. It's almost right. So you're seeing two halves of a circle here. You're essentially seeing two halves of a circle. That's what you're seeing. So wouldn't it be neat if we made it into a circle? How do we do that? So we just need to take it and then draw. We need to change x, how x works. How do we draw this as a circle? Because it's essentially, you're essentially training an AI model to draw a circle here, but it's a sine wave. So we just need to reverse it somehow. So we've got the up and down. We've got the up and down. Now we just need, if it's over 0, I think what we need to do is we need to apply some math to see if it crosses x. If it crosses x on 0, that it could jump back around. So it jumps back around. Although it's still gonna not draw because x is interesting. How do we do this? Flip y-axis over x equals. Is that what it is? Is that what it is, user? Flip y-axis at x0. Yes. All right. I don't even know how to do that, so I'm not familiar. How do we do this with NumPy or with Matplotlib? Where would we do this? Oh, so x.numpy. Right. So how do we do it? So there's two lines here. We're plotting two lines. The original line, right? The original line, which is sine x, which is the original. And then the AI's line is right here. I know that part. I know that much. This is the AI output right here. And so in order to draw a circle, you said flip y-axis over x equals 0. Now, where would we do that? How would we even do that? How do we do that? So all we have to do, so we're almost there. This is the last thing we're going to do, and then we're wrapping up for the day. So how do we flip y-axis at x? Yes. Flip y. Oh, perfect. Okay, so let's bring that up here. So here's the y-axis. We need to bring that top part over. That's what we got to do. I don't even know how to do that. I'm not sure how I would do that with NumPy. So let's see here. Output detach, which brings us into a NumPy direct. So really, all we have to do is draw this right here. So flip over y-axis at x equals 0. We can do this. I know we can. This is like one of the simple things in life. We could absolutely do that. Let's see if we can make it. All right. So what we should do is, so if x, okay. So here's, all right, y. I'm just trying to think about it for a second. How would we modify to x? So if we just see, the problem is if we modify x again, it will just draw back over itself. So we have to modify y. We don't want it to redraw on itself. That wouldn't make any sense. So we need to modify y. So that's the part that we need to modify. So when x is greater than 0, we need y to be negative, or is that what we do? We need y to be negative. Would that work? Or I'm not even sure if that would work. Let's see, because the axis is right here. If the axis is right here, then we just need to flip it. That's the thing. So as we're going through x, that's good. We still need x to increase, but we want y, and then y. But what we did it. We did it. It's not quite a circle, but it's close enough. We're saying. I think it works pretty well. Check it out. Can we zoom in on that? Can we make it bigger? Yeah, we can. We can make it bigger. We can make it a little bit bigger. So it looks like that. There you go. We flipped it. We drew it over the top of each other. Not quite a circle, but it's almost a circle. We probably use cosine as well to do it. It also returns an array. It doesn't mutate the parameter array. That's what it was. That's what it was the whole time. I'm